start with the star. You could do star, smiley face, heart, or you could do star, or not heart, sorry, flower. Star, smiley face, flower, or star, flower, smiley face. Okay, and then you can do the same thing with the other two objects. Like you could start with the smiley face and then do star, flower, or flower, star, and then start with the flower first. So 6 total. So 6 total. And the calculation technically that we're doing is we're using a factorial. Do you guys remember the exclamation point symbol? All right, so a factorial, don't remember that, is where you multiply that number by all the integers below it all the way down to 1. So in that last example, you had 3 objects that you were ordering. So 3 factorial, which is 3 times 2 times 1, is the number of ways that we can order those objects. Okay, so a permutation is what we call this. Permutation is a way to order objects. And if you have n objects, n factorial is the number of ways that you can do that. So example, the objective of a 9x9 Sudoku number puzzle to fill in the grid is that each row, column, and 3x3 grid contains the numbers 1 through 9. How many different ways can the first row of a blank Sudoku grid be filled? Okay, so just the first row must contain all the numbers 1 through 9. So we have 9 objects that we are ordering. So how many ways are there for that to happen? Yeah. So 9 factorial, which you're going to need a calculator for that, definitely. Now, you can type that in 9 times 8 times 7 times 6, da, 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 da. Or in your graphing calculator, on here, if you hit math, go into the math menu. You guys probably want to find this. We're going to use it for a couple different things today. Hit math, go over to where it says PROB for probability. And then the 4th option is your factorial symbol. Okay, so that's where you can find it. So math, probability, and then your factorial symbol. Now, right above the factorial symbol, you'll see NPR and NCR. We're going to be using those in a minute, too. That's going to be combinations and permutations in a few minutes. Those 3 things are also in the red calculators. You're going to be able to use at least the red calculators on your test. And it has a factorial option, and it also has NPR and NCR, and it's all under a button that says PRB on the red calculator for probability. So they're very similar no matter which calculator you're using. All right, so let's see here. Bless you. You should get 362,880. Make sense? Any questions? No? Okay. All right, I'm going to skip over that second example because it's pretty much the same thing. All right, so now let's say you have n objects, but you don't want to use all of them. So maybe I have 9 numbers, but I only need to choose 4 numbers. Or I have 10 people, and I only need to choose 3 people for positions of board members or something like that. So that's when we say we have permutations, take an R at a time. So n is our number of objects, our distinct objects, and we use the word distinct because we want them all to be different. We want to be able to differentiate when we start ordering them. So all n objects are different, and we're taking R of them. So that's how many you're choosing. The notation that we use for this is NPR. So we would read that as n choose R. We have n objects and we're choosing R of them. And then we're deciding again, how many ways can we order that set of R objects. The formula that we use for this is as follows. Still n factorial, but now we divide by n minus R factorial. Okay, so an example, how many ways can you form a 4-digit code where no digit is repeated? So if we're talking about digits, we did this before. How many digits options do you have? 10 digits. Okay, so how I would choose this is I would do 10, choose 4. Okay, I want a 4-digit code out of 10 digits possible. None can repeat. So my formula would look as follows. 10 factorial over 10 minus 4 factorial, which is 10 factorial over 6 factorial. Now, you don't need a calculator to do this, although you could. You could type the factorial symbols in there. You could even use the NPR button in your calculator and put 10 and 4 in there. That would work fine as well. You can do this by hand though. So we know 10 factorial means 10 multiplied by all the numbers below it. We know 6 factorial means 6 multiplied by all the numbers below it. What ends up canceling there? Yeah, 6 and everything after it. So really, 10 times 9 times 8 times 7 is going to give us our answers. That's what we're calculating. And you could probably figure that out without needing any of this formula stuff. If I have a 4-digit code and I want all 4 digits to be different, we did this a couple sections ago. You have 10 choices for the first number, 9 choices for the second number, 8 for the third, and 7 for the fourth. So no matter which way you think about it, you're going to get the same answer. Okay, and then however you want to type it in, you should get 50, 40. Okay. When we're talking about permutations with a P, order matters. Okay. If I'm talking about a 4-digit code, the order of the digit matters. If I have 4, 3, 2, 1, that's a different code than 1, 2, 3, 4. All right, the one below it, psychologist shows a list of 8 activities to a subject in an experiment. How many ways can the subject pick a first, a second, and a third activity? So again, order matters here because one activity is first, one activity must be second, and one activity must be third. They're positioned a certain way. So how many are we choosing from? What's our N? 8. And how many are we choosing out of the 8? 3. Okay, so try that one with your calculator, maybe. Yes?
Could you not simplify the 10 over 6? Or is that...
You cannot any more than what I did to the right of it there. Expand it and cancel. Okay. So 8, choose 3. Again, if you want to try it with your calculator, go into that math. Over to probability. Option number 2 with the P. And you should get 336 different ways for them to choose their activities. Everybody find that okay in the calculator? Yeah, any questions on this? Okay, moving on. All right, so we're going to skip over the you try. All right, moving on to distinguishable permutations. Distinguishable permutations is something that we talk about when within the group we have 2 things that are identical. Like here I have letters. I have 4 A's, I have 2 B's, and I have 1 C. All of those A's look exactly the same. So if I put the 2 A's first and 2 A's last, that will look the same as if I swap those 2 A's. So that's not what we call a distinguishable permutation. So if you want the number of distinguishable permutations, if you have objects in the group that are identical, this is what we do. N factorial, again, that's our total. And then we're going to divide it by all of our n's, where the n1, the n2, the n3 are the number of objects of a certain type. Okay, so let me show you what this would look like with the letter example at the top. I have 7 letters in that group. So my n factorial would be 7 factorial. Then my denominator is all the different types I have that repeat. So for example, I have 4 A's. I have 4 objects that are identical, so that's my first n. 4 factorial, my n sub 1. Then I have 2 B's, 2 factorial, and then I have 1 C, 1 factorial. Those numbers on the bottom, 4 plus 2 plus 1, should always add up to your n, 7 in this case. And then that's what you type in to figure out the number of distinguishable permutations. Okay, so my numerator, 7 factorial is going to give me 50, 40. My denominator is going to give me 48. And if we divide those, we get 105. Distinguishable ways to order those 7 letters. All right? Good? Yes? 4 factorial times 2 factorial times 1 factorial. Or you could do 4 times 3 times 2 times 1 times 2 times 1 times 1. You can expand it out if you want. Oh, okay, so you need to put all that stuff in parentheses if you want to do it that way. Or I would do alpha y equals, set it up that way. When your calculator is dividing, then it's multiplying by this last order of operations. Okay, so, how about we find a friend, try these two. Go ahead, find the number of distinguishable permutations. Find a friend. All right, let's see how you did. All right, answers. First one, 13,860. Second one is, what is that, 77,597,520. Questions? Yep.
So it doesn't matter which order they're in?
The denominator, no.
Yeah.
Nope. All right, so let's do this one together. How many different 9-letter words, and we put words in quotes because they don't have to be actual words, just ways that we arrange these letters, can be formed with the letters in each word? Okay, so the word dragonfly has 9 letters. So my N is 9 factorial. It's my numerator. Do we have any letters that repeat? Any identical objects? We do not. So you could, if you wanted to, divide by a bunch of 1 factorials here, but is that going to change our answer at all? Because 1 factorial is just 1. So truly what we're doing here is we have 9 objects. They're all different. They're all distinct. So 9 factorial is just going to be our answer, whatever that is. 362880. That's the one there if you want. Okay, butterfly, also 9 letters. Do we have any objects that are identical? Any letters that are identical? I have 2 T's, so what do I divide by? 2 factorial. Are there any other ones that are identical? No. So again, you could divide by a bunch of 1 factorials if you want to add up to that 9, but we know that's not going to change our answer. So it's just 9 factorial divided by 2 factorial, which is just 2. And I'm going to get 181,440. Okay. Bumblebee, another 9-letter word. Do I have any identical letters? I have 3 B's, 3 E's. That's it. So what do I divide by? 3 factorial and 3 factorial. And you should get 10,080 ways to arrange those objects. Okay, different words that I can make with those letters. Questions there. Distinguishable permutations. Nope, nada. Okay, good. Moving on. All right, so now all of those problems were if order matters when I select a group. So we place things first, second, third. If order matters, we use what we call permutation. If order doesn't matter, if all we're doing is choosing a group and each within the group doesn't have any specific positions, it is not called a permutation anymore. It is called a combination. So order does not matter. This is probably going to be the toughest thing when you're doing your homework, is whether you know that you're doing a permutation or a combination. If order matters, it's a permutation. If order does not matter, it's a combination. The formula is a little bit different here. You can see the notation is that big one with the C instead that you're going to use in your calculator. Okay, same formula as the permutation. We just divide by a little bit more. Divide by an R factorial in addition to that. Okay, so when we talk about order not mattering, the example at the top is an example of this. So a state park manages 5 beaches that are called A, B, C, D, and E. Due to budget constraints, new restrooms will only be built at 3 of the beaches. There are 10 ways for the state to select the 3 beaches. What are they? So for example, the state could choose beaches A, B, and C. And it doesn't matter what order they choose them in, because no matter who is selected first, second, or third, they're all just going to get identical restrooms, okay? Or they could choose A, B, D, or they could choose A, B, and E. So we're picking, rather than positions, we're picking groups when we do this. I could choose A, C, D, or A, C, E, or A, D, and E. Or I don't have to use an A at all. I could use B, C, D, or B, C, E, or B, D, E, or C, D, E. Those are my 10 ways. Okay. And none of those sets have identical sets of 3 beaches, I guess. So there are 10 different ways for that to happen. Okay. CDE is the same as EDC. We'll make those selections. All right. So example, do the one at the top. A Department of Transportation plans to develop a new section of interstate highway and receive 16 bids for the project. The state plans to hire 4 of the bidding companies. How many different combinations of 4 companies can be selected from the 16 bidding companies? So there's no information here regarding the fact that order matters. It doesn't matter who is selected first, second, third, or fourth. They're all getting the exact same bid. So all we're doing is out of 16, we're selecting 4. So with your calculator, you can just do 16, choose 4, but you're using the one with the C in your calculator now instead of the P, okay? And you can do it out by hand if you want to. The formula would look as follows. 16 factorial divided by 16 minus 4 factorial times 4 factorial. Or again, the calculator will do it for you. Okay, so under that probability menu, pick the one with the C. 16, choose 4. 1,820. Different groups of 4 companies we can select for bids. Make sense? Good? Great. Okay. So now we're going to skip over the calculator slide. We already talked about the calculator. Last couple slides are about probabilities and our combinations put together. Okay. We want to here find the probability that you are being dealt 5 diamonds in a hand of 5 cards from a standard deck of 52 playing cards. When we're talking about probabilities, remember you are dividing. So you are dividing how many ways something can happen divided by the total options that would be available to you. Okay, so let's start with, if you have 52 playing cards and you want a set of 5 cards, what do you calculate? What do you use, a C or a P? Start with that. Combination or permutation? It's going to be a combination, because does it matter what I hand you first, second, third, fourth, fifth? No. The hand of 5 cards that you get will be the same. So we're selecting 5 cards out of a group. That's my denominator. That's how many different ways I can get a set of 5 cards out of a 52 card deck. Okay? Now your numerator is the probability that you're calculating. Here the numerator is how many different ways there are to get 5 diamonds out of a deck of cards. So how many diamonds are there? Yes, so flip that. So from 13, we're available to choose 5 of those. So there are 13 choose 5 ways to pick a hand of diamonds. There are 52 choose 5 ways to deal a hand of 5 cards. Divide the 2, you have your probability. Let's see what we get. 13, choose 5. 52, choose 5, and I get 4.95, and then it says E. Remember, the E means times 10. It says E -4 times 10 to the -4th. So it's, if I give it a few decimal places, that probability, 0.000495.
But we can't use.
You can use the red calculator, and the red calculator also has buttons for this.
Wait,
With the C, it has a
13C5.
yes, it has the C, it has the P, and it has the factorial. Before the test, I'll show you where all those are at. We'll practice with it, but it works the same as a graphing calculator. Yeah. All right, bottom one, slightly edited version of the top one. It says, find the probability of being dealt 5 diamonds, but this time we have jokers in the deck. In this case, a joker is considered to be a wild card that can be used to represent any card in the deck. So how many cards are we choosing from this time? 54. And again, we're choosing 5. How many cards in the deck are considered diamonds this time? 15, because the jokers could count as a diamond. But again, we're choosing 5. So you can just edit your previous thing that you typed in the calculator there if you want. 15, choose 5. Divided by 54, choose 5. So I get 9.496 times 10 to the negative 4th, which is about 0.0009496 if I give it a few decimal places. A little bit higher probability there.
How do you get like when it comes up for the it brings up the answer like when I go over the answer just like
Oh, okay. So
I can't do that either.
hit the number first. So hit 15 first. And then in math, go over to,
That's how I did mine.
yep. And then, yeah, you might, yeah. So yours will just look like
So do like that?
Yes.
Alright.
So that's the numerator.
Yeah,
So you
yeah.
gotta do the denominator.
But that's what's gonna look like that.
Yes, yes. Yeah. Yep. Okay. One more slide we're going to do together, and the last problem will be yours to try. A food manufacturer is analyzing a sample of 400 corn kernels for the presence of a toxin in the sample. 3 kernels have a dangerously high level of toxin. 4 kernels are randomly selected from the sample. What is the probability that exactly 1 kernel contains a dangerously high level of toxin? Okay, so again, it's a probability, so let's start with our denominator. How many kernels are we choosing from? 400. And how many are we picking? 4. And does it matter what order we pick them in? Order does not matter. We're just picking a group of 4 out of the 400, so it's, again, a C, a combination. Okay, now the numerator, we want only exactly 1 that has a toxin. The other 3 then will not have the toxin. So you're going to have 2 different sets of information in the numerator. Ways to choose the 1 with the toxin, and ways to choose the 3 that don't have the toxin. Okay. How many kernels in the set of 400 have a high level of toxin? 3. And how many of those are we choosing? 1. How many kernels out of the 400 do not have the toxin? 397. And we are choosing 3 of those. If you're not sure when you set these up if you've done it correctly, the left side of your combination notations should add up. So 3, 397, 400. And the right side should add up. So 1, 3, 4, if you've done that correctly. And then you just type the whole thing in your calculator. You might have to do that in chunks. So let's see, 397, choose 3 times 3, choose 1 over 400, choose 4. And I get 0.0296 if I give it 4 decimal places. Good? Make sense? Okay. All right, the last one you're going to try. I'm going to give you a hint for it, though, because you have to use a chart of information. You got a pie chart here. So the pie chart shows how many adults rate their financial shape. Suppose 18 people are chosen at random from a group of 300. What is the probability that 5 of the 18 would rate their financial shape as poor? So when it's worded like that, 5 are rating it as poor, Everybody else is saying my financial shape is not that category, not poor. Those are your two choices, okay? Now, what you need to know from this graphic is exactly how many people rated their financial shape as poor. And they're not giving us a number here, they're giving us a percentage. 13% of what? 300. So you need to do that math first. 13% of 300 gives you 39. There are 39 people in this group of 300 that have rated their financial shape as poor. Okay, so see if you can set it up and calculate that probability. It's very similar to the kernel example if you want to use that to help you. All right. Answer 0.049 is your answer. So your denominator start there. 300 in the group. You're choosing 18 people. Remember, the first two pieces on the left need to add to 300. So 39 people rated themselves as poor out of the group, which means 261 did not rate themselves as poor. Out of the 39, 5 of them are what we're selecting that rated themselves as poor, which means 13 are rated themselves as not poor. And when you type that all in, you get 0.049. Okay. All right. So math Excels. Your math Excels are pretty much due every other day. So you had 3-1 due last night. 3-2 is due tomorrow night. 3-3 is due Sunday night, and 3-4 is due Tuesday night. Every other day you've got an assignment. Tomorrow in class, we are going to collect data for project number 2. You get Skittles tomorrow. And then the rest of the period will be yours to work on math Excel. On Monday, we will have a quiz over 3-1 to 3-4, our probabilities. It will be a group quiz. You will be allowed to work in groups of 3 or 4 on that on Monday. Yes. Yeah, I think you can use your notes on that. I don't think that'll. Yeah, that's fine. You can use your notes. That's good. And that's it. Any questions on that stuff? No? Okay. You can wrap it up, save what you have, put the computers away. You got, like I said, we get out of here at 11:11. You got like 8 minutes. And I'll do cell phone lotto.